Jai Hind everybody. I am Dr. Rashmi Sharma from Department of Information Technology, working in ABS Ajay Kumar Garg Engineering College. Today I would be discussing one topic of Unit 2 of Data Analytics subject, which is being taught in BTech third year, and the topic is fuzzy logic. So, what would be the different the syllabus of this particular unit 2 comprises of this, and the things which we would be discussing it, how we extract this particular models from the data, how can we do that, what do we mean by fuzzy decision tree, and what are the stochastic search methods. Then the concepts which would be dealing into this particular topic is definition of the fuzzy logic, what is the history of this particular fuzzy logic, what are the different characteristics of the fuzzy logic, architecture of fuzzy logic, that is when we have a rule based system or when you are using a fuzzy logic system, FLC. So in FLS, what are the different, what is the architecture do we follow, and some of the examples, or I can say the application areas of fuzzy logic. So the keywords which would be discussed is fuzzy. What do we mean by fuzzy? How it differs from Boolean algebra, which we usually do it, or you might have studied in discrete structures also, and might have studied in 11th and 12th also. Then what do we mean by rule base? What do we mean by fudgification? How we infer a particular engine, how an inferencing engine is being used, and what do we mean by defuzzification? These are some of the keywords which we would be coming across in this particular video. So coming to the first thing, fuzzy logic. What do we actually mean by fuzzy logic? The word fuzzy, this word fuzzy, it means something that is not clear or something that is vague. So something which is dizzy or that is not clear, or having in Hindi we can tell dhundla. So something that is not clear is your fuzzy. So we cannot decide on in our real life whether this particular problem is truly occurring to me or not. Like if I have a temperature, the normal body temperature is 98.6, and if I'm feeling something down in my day to day, and if I have a temperature of 99 or 99.2, so do it comes under that I'm a normal person today, or do I have a fever or I'm feeling feverish? If temperature 100 is there, definitely you are having a fever. But if it is in between something, it is not that that you are feeling feverish, but from internal body you are feeling feverish, but actually you are not. Maybe actually you are not. So in real life we cannot decide on that particular point of time whether we lie into this region or we lie into this region. That is called as the fuzzy. At that time, when concept provides many values between true and false, we would be coming into the examples where actually we can understand how we deal with this particular problem. And then the flexibility is we want to find the best solution for the problem which is arising. Whether I'm feeling feverish or not, if I'm feeling low and I'm having a body ache and I'm feeling lethargic, then we usually take a paracetamol and we feel happy, or we feel fine after 2 to 3 hours. That is actually what it should be the solution, so that we can have a fit and fine body. Then see, the example of this fuzzy logic is whenever you look into the water, the temperature of the water, is this water hot or is this water hot? So you can have two answers in your Boolean logic, yes or no. But sometimes when like I am habituate of drinking a tea which is lukewarm or a little hot, but not too hot, not the shimmering hot. I don't drink that particular tea, but some people might drink that particular shimmering hot tea. So according to them, when the temperature falls down by 20 degree also of the tea, they say chai to thandi ho gayi. But for me that is fine. I keep the cup for 5 minutes and then I drink the tea. So you don't have this particular only the answer in some of the questions which are related to our day-to-day life. So like we can have, yes, it's very much, yeah, it's very hot, yes, very much hot, a little hot, or I can tell a lukewarm water, and it's very less, or thandura in Hindi what we tell. So we can have some sort of things which are in between this 0 and 1, and that is where the fuzzy logic comes into picture. So for this particular example, I can tell in the fuzzy logic, or we have come across because we have some problems related with the Boolean algebra. So in the Boolean algebra, we have only two possibilities, 0 and 1. Like in the signals also, in computers, we have two values, two binary values, either 0 or 1. And when, remember, when we are having a continuous waveform, that is a sinusoidal waveform, what we tell, if we have a value above 0.5, we consider it as 1, and if it is below 0.5 and greater than 1, greater than 0, then we consider it as a 0, and we usually draw that particular diagram as this values, abruptly increasing and abruptly decreasing. But actually it's, you have some wavy form, we have a continuous form, and we usually convert it into a discontinuous form. So here we have values which are discontinuous, 0 and 1, a difference of this. But in fuzzy logic, we try to have a multiple possibilities of that particular same thing. So for what can be the multiple possibilities? All the values between 0 and 1. Like in probability, if it is a 0, then it doesn't occur. If it is 1, it would definitely occur. And in between, you have a probability of occurring an event and not occurring an event. Similarly, in fuzzy logic also, we have the same probability lying between the range of 0 and 1 for occurring or being in that particular state or not being in that particular state. So we can compare this fuzzy logic in a layman terms with the probability which you have studied in class 8 also, in class 10th also, and in class 12th also. So this particular fuzzy logic is a layman example, I should say. For a layman, I would say that is an example of the probability which they have studied in the school. So the two possibilities, 0 and 1, exist, where 1 denotes the absolute truth, that it would definitely occur or it is definitely true, and for 0 it is absolute false. So in fuzzy logic, there are multiple possibilities. In multiple possibilities that have a value between 0 and 1. So you can have a partially false also, you can have a partially truth also. So you can have a number of values. Obviously, as I told, ranging between 0 and 1. For 0, it's absolutely false. For 1, it's absolutely true. So what is the history of this particular fuzzy logic? How it came into picture? So fuzzy logic contains multiple logical values. Definitely logical values between 0 and 1. It should have all, it can have all the values between 0 and 1. Okay. So these values are the truth values of the variable which lies between 0 and 1. This was first of all given by Lofty-Zadeh in 1965, were naming as fuzzy set theory. We have a Boolean or a normal set theory which tells either if I have a set A, okay, and this element has 0.1, 0.3, 0.5. So the probability of 0.25 being in this particular set is 0.25 does not belong to this particular set, means 0.25 does not belong. But in fuzzy logic, we have some probability of here, how we will look into the incoming slides. So this concept provides the possibilities which are not given by computers and similar to the range of possibilities generated by human. Maybe, can be, these are different words, can be, maybe, should be, will be, would be, depending on the definiteness of that particular verb, we have this particular range of values. So fuzzy logic can be implemented in the systems such as microcontrollers, workstations, or the network based systems where we require a definite output. And definitely when these particular values come, we have some inferences to be drawn, and according to those inferences, we take some particular action. So that's why we have a fuzzy logic system also. So, and it can be implemented in both the hardwares and the softwares. So we can have a programmatical form also and in the hardware also. So coming to this particular point, where do we have exactly this fuzzy logic system implemented in the hardwares? You all might be having your ACs at your home and you set this particular timer, and then when that particular timer goes off, then your system also shuts down. That is a fuzzy logic system which is being implemented into that. Your refrigerator, when it is being opened for 2 minutes and more, then it again gives us a beeping sound, and that beeping sound is again a fuzzy logic which is being implemented in this particular hardware of your refrigerator. Whenever you are telling your washing machine, the fully automatic washing machine, to have a gentle wash to your clothes and not defining the temperature, then the gentle wash has a range to have the soap of that particular quantity from your soap cases, and having the temperature of the water to be controlled by that particular washing machine. And in that particular washing machine, the system which is built is fuzzy logic system. So here the hardware comes into picture, and actually how hardware works is through the programming which is done by this particular softwares. So what are the different characteristics of the fuzzy logic? First is the concept is flexible. Obviously, it has some values between 0 and 1. So it is giving a flexibility of all the values between 0 and 1. So it is flexible. It can be easily understood and it can be implemented actually in your real life. I gave you the examples, 2 or 3 examples. So it is used for helping the minimizing the logic which are being created by human. मुझे इतना गरम चाहिए, मुझे इतना चाहिए. So you have some specific, the itana vitana, the words which we usually use. I want a lukewarm water, but not too cold, not too in between of that, not sizzling hot also, and all those things. So when you are having ifs and buts and different words, then definitely this has a specific range of values. So we are defining that particular range. If it is between, the temperature is between 25 to 30 degree, then it is the lukewarm or the semi-lukewarm water which that particular person wants, and that is being designed in the system along with the software also. So it is the best method for finding the solution to those problems which are suitable for approximate and uncertainty reasoning. So we should know we have some uncertain problems where the definiteness of that value is not. I'm actually not telling that I want 25 degree temperature, otherwise you would have put a thermometer and told, oh, it's 25 now, take out from that particular gas or the stove. So here we have some undefiniteness or uncertainty in that particular problem or the statement. So to define that uncertainty, we require fuzzy logic. It's always offered 2 values which denote the possible solution for the problem and the statement. So definitely, as I told, that we would have a range. If I tell the temperature should be between 25 to 30. So if that particular person gives you something related to 31 also, then you would be okay because you have defined a range. Plus minus something does, and 24 also would be valid. But if I tell only 25, discrete value of 25, then it won't go with 31 and it won't go with 24. So we give a possible range so that we can have a problem also and the statement also to justify that particular thing. So it allows users to build and create the functions which are not linear of arbitrary complexity. Definitely, when we are having a range of values, we don't have a discrete value. When we are having a discrete value, means you have a dependent and an independent variable. Here we have a non-linear function. We are not, non-linear is definitely of, this is a linear function. Okay? Linear is you have y which is related with x in the same power. Non-linear is maybe y is related to x with the power of x, or y is related to y with inverse power of x square, or y is related with log of x. So that shape is not fixed. Here you have the same power. Obviously that in linear, the word as the linear, the word denotes it should have a power of 1 only. So the next characteristics is, in fuzzy logic, everything matters is the degree, how the range. If it has to lie more towards 1, then it may have a value of 0.99 also, and 0.8 also would suit that particular value. And if it is near to 0, then 0.1 also would suit that particular value. So in a fuzzy logic, any system which is logical can be fudgified. Obviously, anything which can be defined logically can be fudgified. It is based on NLP, that is natural language processing. That is the basic thing. Nowadays, n number of works are being done into NLPs. Your Siri understands what you are telling, your Echo understands what you are telling, your Alexa understands what you are telling. So this is all on your NLP. And when you speak out, when you tell something, the other person or the listener understands your feeling, it justifies that particular words, and then gives you the result output. It also is used by the quantitative analyst for improving the algorithm's execution. We want more performance, more throughput, less time execution, less space. So all these things are being taken care by your quantitative analyst while using the fuzzy logics. It also allows users to integrate with the programming. As I told, we integrate with the software also. So the architecture basically, this is FLS, fuzzy logic system. All those hardware systems like washing machine which I talked about, your AC remotes which I talked about, your refrigerators which I talked about, even when you have the sensors which is telling that your car is near to the another car very near to that, then there is a fuzzy logic system, because we have not defined exactly the range. We take an approximate range, and in that particular approximate range we define that particular beeping sound or the signal which is coming to us. So this particular architecture of fuzzy logic FLS system, we have 4 components, and each and every component plays a very important role. So the architecture has different components. First is the rule based system. Definitely this rule based system is somewhat in a normal language or a student language. If I tell you, it's somewhat like your if then else loops or your decision trees. If this then this, if this then this, if this then this. So you have these particular if then else loop. Obviously, these if then else loop have a specific range. When you have this particular range, then you are doing this particular fudgification. Obviously, coming to again one of the examples, whenever you are giving some particular rating or a feedback, if I ordered some particular product from the Amazon and I have to give a feedback of that particular product, if I have used for 1 month and now I have to give the feedback of that particular product, and they have some verbal words, not on a scale of 1 to 5, but they have something verbally which I have wordly meaning, textual, which I have to write. If I wrote it is very good, or I wrote it's excellent, or I wrote it's very poor in quality, you can have anything which you are writing, the words which are coming to your mind, the textual form you are converting it. So when these textual forms are being converted, then I require that because whenever you see a product, you are scaling that on the scale of 1 to 5. You are seeing that if the or a movie rating also, you get 3.4 or you get 4.2, something rating is there for every product or the movie which you go for watch. So how do we get these particular things? So we have defined this rule system. If I get something like this or this or this or this and or this, I will grade that particular system as 1. This or this or this, something between, then I will grade it as 2. And so on, so thing. So when I am having this if then else, I am doing some textual form. When you are converting this textual form to your when you are converting some of your numeric forms to your textual forms, textual forms to your numeric forms, then it is your fudgification. So when you have something in textual and then now you're converting into numeric form. So look, we will coming to this particular, you have this particular system. So in this particular system, I have these rule based system, and from these rule based systems, I have defined these rules which I told we have if then else, something like if then else. I'm defining you like this. Okay, we have nested if then else, and you have this inferences engine for all those then conditions. You have engines to infer. If your refrigerator gets open, even it's a partially open, but you get a beep sound, it's not wide area open door, I have a finger gap, and then also after 2 to 3 minutes my refrigerator starts beeping. So that is the inference engine has to infer what amount it is open, but if it is open, you have to give this particular signal. So for getting this particular signal, you have this crisp input, and that input is being converted into your fuzzy thing, and you are giving this fuzzy input to your inference engine. So you have I have converted that textual form. See, this textual form is converted to your numeric values. So now these numeric values are being given as input, and you are getting some textual as the input to this particular, and you are again getting this particular textual output. So this numeric values convert to your text values. Your text values are again converted to your numeric values. So your fudgification, what is your fudgification doing? Taking the numeric value fudgy module and giving the fudgy output. And this defudgification is taking your textual values and giving a numeric output. So you get a output as a range of 1 to 5 of your particular values. So what you are giving? You are giving those particular very awesome, good, excellent. So these particular values are being given, but these values are to be again converted into, first you convert that into numerical values. According to those numerical value, they convert into the text which this inference engine understand. We don't have that particular big data set. So the inference engine understands some of the rules only, otherwise hundreds of adjectives and the verbs and the words are there. So if I use all those particular words here, definitely my inference engine would be too long. So I have some specific set, assume I share 100 set of rules which are being defined. So I have to see whatever the user writes in this has to get converted into this particular numerical form, and this numerical form is being given as an input. Then it converts into a textual form which our inference engine understands. Then this textual is again converted into this crisp value. So this is the architecture of fuzzy logic system. So what do you mean by rule base? The rule base is component used for storing the set of the rules. If I told you that is all if then else loops. If then else condition given by the experts are used for controlling the decision making system. And there are so many updates that come into the fuzzy theory recently that offer effective methods for designing and tackling the fuzzy controller. You might have seen previously we were having only the machines with the timer and the spinners. Now we have the water temperature also. We have the caring also for the clothes, like you want to do it with the steam or a gentle wash and so on and so forth wash. So these updates and the development decreases the number of fuzzy sets of rules. We require less because whenever we are going, if gentle wash, then I have to follow these rules. If it is temperature is 20 to 30 degree, I have to take this particular set of actions. So we are segregating that particular thing by using some of the basic rules. Then what do we mean by fudgification? So fudgification is the module or the component that transforming the system inputs, it converts the crisp value to the fuzzy output. So we are converting this crisp values into the fuzzy outputs which is being understood by our inference engine. So the crisp values are those inputs which are measured by the sensors. If when you are using a sensor like the temperature is falling down, or what temperature we have told them to get, or a gentle wash. So obviously these are the sensor of values, and then the fudgification is passed to the control system to get that particular further actions. So when we divide this input signals, we can divide it into 5 different values: large positive, medium positive, small, or medium negative, and large negative. So these are the range which we divide, and according to this particular range we can have different rules which we can have for this fudgification. We usually take this as the medium center value. This is the center value, this is extreme positive, and this is extreme negative. So we take this particular, we usually have a range of 3 in the multiple of 3, 5, 7 and 9. Obviously, because the middle value becomes the center one, and you can vary it similarly on the both the sides. Like see, we have this particular signal. If this is my center values, I have 0, these values on plus and minus both the sides. So we have to track those particular values. So we take a range of the odd number values. Inference engines, this component is the main component where we actually do the actions which we have to do. So of the fuzzy logic system, it is processed in the inference. It allows users to find the matching degree between the current input fuzzy input and the rules which we have defined. So the most appropriate match which they are finding it, they take that particular respective textual form, and then they look into the inference engine. After the matching degree, the system determines which rule is added according to the given input field, which condition they have to fulfill and what action they have to take. When all the rules are fired, then they are combined for developing the control actions. What actions do we have to take? In the defudgification is the module when we take the fuzzy values and which has been generated from the inference engine, and then we convert that into the crisp value. It is the last step in your fuzzy logic system, and the crisp value is acceptable to the user. If it is not, then we have to look how different outputs which we are getting into it. So the various techniques are present to do this, and we have usually center of mass, center of gravity, center of area. These are some of the techniques which we used for defudgification of the values, because we have that particular span and now we have to find a single value which we have to give it to the user. So various techniques are present to do this. The user have to select the best one depending on the case study. So what are the different application areas of the fuzzy logic, or I should say what are the different examples which we usually have in our day-to-day life for our fuzzy logics? So first is it is used in the businesses for decision making support system, DSS. Then it is used in automotive systems for controlling the traffic speed and to improve the efficiency of automatic transmissions. Now when we have this particular unmanned vehicles, so these automotive systems also have the shift scheduling method, which shift is working when and where we have to do this particular shifting. Then this is the method for your automotive transmissions. This concept is also used in defense. Defense mainly uses the fuzzy logic for underwater target recognition and the automatic target recognition in the thermal infrared images. So they look into those particular images and let you know. So fuzzy logic system is used in the securities. It can be used in pattern recognition and classification. It can be used in microwave ovens for setting the loom powers and cooking strategies. And similarly, this technique can be used in the modern control systems. Finances, nowadays also we are using this fuzzy logic into the finances for managing the funds which we have to invest where. It is used for controlling the brakes of the automobiles in the industry, chemical industry, in the industries of manufacturing for optimization of the milk and the cheese production, which milk is sufficient for which type of commodity. It can be used in vacuum cleaners, timing for the washing machine, it is used in heaters, air conditioners and the humidifiers which you have in your home. So these are some of the systems where we use fuzzy logic. So what are the advantages? This concept is similar to what human reasoning is there, and so we have a very easy understandable way for the fuzzy logic. So we do not need large memory, we only require an inferences engine where you have those particular rule based system, because the algorithms can be easily described with fewer data. So it is widely used in the field of life, and you can effectively find the solutions for those particular problems which have high complexity. And this concept is based on the set theory of mathematics. That is why it is very simple to be implemented. So major what are the disadvantages is the runtime of the fuzzy logic is slow, real time runtime is, and long time is required to generate the output because it goes through if then else, and you might be knowing that when you are running if then else, then you are jumping into your memories also. So users can understand it easily if they are very simple. The possibilities produced by the fuzzy logic system are not always accurate, and many researchers give various ways of solving the given statements, and which may lead to ambiguity in solving those particular problems. The fuzzy logics are not suitable for those problems that require high accuracy. Usually when some problems or some loopholes are okay, then we use this particular fuzzy logic. The systems of fuzzy logic need a lot of testing. So these are some of the things which we so what do you mean by fuzzy decision tree? It is based on the reduction of classification ambiguity with fuzzy evidences. The tree contains many branches in the leaves, and like if then else I told you. So each leaf represents a category that is similar to the specific objects, and the root node have represents the category that has no subcategory. That is the main thing. So when we have those bifurcations, we are looking into this. Fuzzy decision trees are more efficient for treating learning data of mixed type, including both numerical and categorical data, and they are most robust in tolerating impressive, conflicting, and missing informations. So these are the some of the points which we have to this. So for conclusion, we have discussed the fuzzy logic system. What are the different architecture of fuzzy logic system? What are the advantages, disadvantages, and applications? These are some of the references which you can go through for your fuzzy logic system. Thank you for this video.